Good morning, all of you. I am Suneetha from Chemistry Department. Today we are going to learn about organic chemistry, hydroxy compounds and ethers lesson. There the two topics are there. Second one, phenols, we are going to continue because alcohols we have already completed. Phenols. Phenols are aromatic hydroxy compounds in which hydroxyl group is directly attached to an aromatic ring. Okay. These are represented by the general formula AROH, where AR is a aryl group, that is either phenyl or a substituted phenyl or naphthyl group. Based on number of OH groups attached to the aromatic ring, phenols may be classified as monohydric phenols, that is which contain one OH group, dihydric phenols, which contain two OH groups, trihydric phenols, that is they contain three OH groups. Monohydric phenols are named as derivatives of the first member of the series, commonly called phenol. But methyl phenols and other di- and trihydric phenols bear the special names. Let us see the examples. First one is phenol, the first member of the series, that is on benzene ring OH group is present. And next example, dihydric phenols. Example is catechol, where two OH groups are adjacent to each other. And next example is orthocresol, where toluene on toluene OH group is present in ortho position. And next one is two OH groups are present meta to each other. This is resorcinol. And next example, another example is quinol, where two OH groups are para to each other. Now let us see the methods of preparation of phenols. The first preparation is hydrolysis of diazonium salts. The phenols are obtained when diazonium salt solution is slowly added to excess of boiling dilute sulfuric acid. That is, benzene diazonium chloride is this one. This is hydrolyzed with sulfuric acid. Then we get phenol. The other products are nitrogen and HCl. This is first preparation. And this is known as benzene diazonium chloride. This is phenyl group. This is Yan2, dimixed 2. Yan means azot. This is chloride, diazonium chloride. Next one is from benzene sulfonic acids. When sodium salts of benzene sulfonic acids are fused with the sodium hydroxide at 300 degrees centigrade, sodium phenoxide is formed, which on acidification, that is when we add acid, it gives phenol. Let us see the equation. This one, C6H5SO3Na. This is sodium salt of benzene sulfonic acid. When it is fused with, that is to this sodium hydroxide is added and heated to 300 degrees centigrade. Then we get the sodium salt of phenol. This is also known as sodium phenoxide or sodium phenate. This when we add acid to this, we will get phenol. This is second preparation. Next one is from cumene. Cumene is isopropyl benzene. See this? Cumene. Cumene is isopropyl benzene. This one is oxidized by bubbling oxygen through it. That is, when we pass oxygen through this cumene, we get cumene hydroperoxide. Cumene hydroperoxide. This cumene hydroperoxide, which decomposes into phenol and acetone in presence of an acid. If we add acid to this cumene hydroperoxide, we get phenol and acetone. So this is another preparation for phenol, that is from cumene. Cumene, what is cumene? Cumene is nothing but isopropyl benzene. That is, this is isopropyl group which is added to benzene ring. Then we get cumene. Cumene, when it is treated with oxygen or when oxygen is bubbled through this, we get cumene hydroperoxide. This on acidification, that is to this, when we add acid, we get phenol. These are the three preparations of phenol. So first preparation is hydrolysis of, see this, hydrolysis of diazonium salts. Second one is from benzene sulfonic acids. And third one is from cumene. Cumene or cumene hydroperoxide. So these are the three preparations. Now let's see the properties of phenols. Properties of phenols. See this, properties of phenols. So the properties of phenols are classified into three types. That is reactions of enolic hydroxyl group. En means double bond, ol means OH. So this group. Next one is reactions of benzene nucleus, and next one is the special reactions of phenol. Now let us see first type of reactions. Reactions of the hydroxyl group. There, the first one is acidic character. First one is acidic character. Phenols are acidic in nature, whereas alcohols are not. So phenols, the acidic nature of phenols, we can explain with the help of this reaction. Where phenols, they react with either alkyl metals or alkalis or hydroxides to form the salt of phenol. That indicates their acidic nature. Let us see this reaction. Phenol, when combined with sodium metal, we get sodium phenoxide or sodium phenate. Another one is phenol when treated with sodium hydroxide. That is alkali of this metal, hydroxide of this metal. Then we get sodium phenoxide or sodium phenate. This indicates acidic nature of phenol. Whereas alcohols, they do not react like this. Therefore, we can say that phenols are more acidic than alcohols. So here, phenols are more stronger acids, are more acidic than alcohols, but weak acids when compared to carboxylic acids or even carbonic acid, that is H2CO3. Now let's see the next property of phenol, that is reduction with zinc dust. Reduction with zinc dust. When aromatic hydrocarbons are obtained, when phenols are treated with zinc dust. Zinc dust is a reducing agent. What it will do, it removes oxygen from phenol. When from this phenol, when zinc removes oxygen, we get C6H6. That is aromatic hydrocarbon. Benzene is obtained in this reaction. This is a reduction reaction where zinc acts as a reducing agent. So phenol undergoes reduction to form benzene in this reaction. This is reduction. Next one is alkylation. Alkylation reaction. So phenols react with alkyl halides in alkaline medium, that is basic medium, to form phenolic ethers. Let us see the reaction. This is phenol. When it is treated with sodium hydroxide, we know that it gives sodium phenoxide. This sodium phenoxide, when treated with an RX, alkyl halides, that is methyl iodide, as a specific example we have taken here. And then we get an ether. Ether, we know ROR. ROR. This is general formula of ether. This is specific ether. Methyl phenyl ether is the ether obtained here. And this is also known as anisole. Another name of this is anisole. So these are the preparations of properties of phenols. Few properties. And let us see the next property of phenol. Next property of phenol. That is acylation or ester formation reaction. Ester formation reaction. This is very, very important reaction. Whenever any reaction is, that is always very, very important. Let us see this. This is Schotten-Baumann reaction. In the examination, they will ask, write about Schotten-Baumann reaction. So we should give the statement followed by the equation there. So this is Schotten-Baumann reaction where phenols react with benzoyl chloride, that is an acyl chloride, which is aromatic acyl chloride, benzoyl chloride, to form phenyl benzoate and ester. This reaction is known as Schotten-Baumann reaction. Now let us see the equation. This is phenol. This is treated with benzoyl chloride, that is on benzene ring. COCl is present. Benzoyl chloride, ZOYL. This combines with phenol to form an ester. This to form an ester. This is known as phenyl benzoate. This is phenyl group. This is benzoate. Phenyl benzoate. This is the reaction known as Schotten-Baumann reaction. In Schotten-Baumann reaction, phenols react with benzoyl chloride to form phenyl benzoate and ester. So this is very, very important reaction, and we know that all base name reactions are very important. And let us see the second type of reactions where the reactions involve benzene nucleus. Previously, we have discussed about the reactions which involve OH group of phenol, whereas here the reactions which involve benzene ring or benzene nucleus. There, the first one is halogenation reaction. This is also very, very important reactions. They will ask in the examination. So phenols, when treated with aqueous solution of halogens, they undergo halogenation rapidly to form polyhalogen derivatives. That is, here, let us see the example. Phenol, when it is treated with bromine, aqueous bromine, that is here, aqueous bromine, that is in presence of water, bromine plus water, let me say. So for phenol, when combines with aqueous bromine, we get a substituted derivative of phenol. Tri-substituted, tribromo phenol is obtained. This is second position, fourth position, and sixth position. Bromine groups are attached to phenyl group. This is known as 2,4,6 tribromophenol, which is obtained as a white precipitate. So this is one of the important chemical properties of phenols. Where phenols combine with aqueous bromine to form 2,4,6 tribromophenol as a white precipitate. This is one reaction where the benzene ring is involved. And let us say the next reaction. And the next reaction is known as nitration reaction, where dilute HNO3. Phenol combines with dilute HNO3, or phenol, when it is treated with dilute HNO3, a mixture of ortho and para nitrophenols are obtained. Because OH group is ortho para directing groups, we get the mixture of both. So initially phenol, when combines with HNO3 diluted, we get ortho nitrophenol and para nitrophenol. So both this mixture is obtained. Here, if nitration of phenol is performed in presence of concentrated nitric acid, we get the 2,4,6-trinitrophenol, that is a polynitration takes place. And this 2,4,6-trinitrophenol is known as picric acid. So this is nitration reaction where the benzene nucleus is involved. Now let us see another example where benzene nucleus is involved, that is sulfonation reaction. Sulfonation of phenol with concentrated sulfuric acid gives a mixture of ortho and para isomers. Ortho and para isomers. But ortho isomer predominates at low temperature, while para isomer at high temperature. Now let us see, this is the example. Phenol, when it is treated with sulfuric acid at about 1500 degrees centigrade, we get ortho isomer. This is ortho hydroxy benzene sulfonic acid. This is benzene sulfonic acid. This is ortho position, hydroxy group is there. Therefore, it is ortho hydroxy benzene sulfonic acid. This is obtained at low temperature. When the same phenol is heated with sulfuric acid at more than 100 degrees centigrade, we get para hydroxy sulfonic acid. So, para hydroxy sulfonic acid. This is para position to this sulfonic acid. So, para hydroxy sulfonic acid is obtained as a major product at high temperature. This is sulfonation reaction where benzene nucleus of phenol is involved. Now let us see another reaction of next reaction, next chemical property of phenol. That is Friedel-Crafts reaction. We know Friedel-Crafts reaction is very, very important. All name reactions are important in case of organic chemistry. So here, phenols, they undergo Friedel-Crafts alkylation and acylation, forming predominantly para isomers. Predominantly para isomer. That is, para isomer is major product, whereas ortho isomer is minor product. Let us see the reaction. Here, the phenol, it is treated with RX, that is alkyl halide, in presence of Lewis acid like AlCl3. Then we get the ortho substituted product and para substituted product, where para is obtained as a major product and ortho is obtained as a minor product. So similarly here with acyl chloride, acyl halide, if X is there, halide you can say. So acyl halide, RCOX, when this phenol treated with RCOX, that is acyl halide, in presence of a Lewis acid like AlCl3, we get ortho and para substituted product, where para is major product. This one, para substituted product is major product and ortho substituted product is minor product. This is Friedel-Crafts reaction. Instead of RX, you can write a specific example, CH3Cl, here CH3COCl, like that. Now, let us see the next properties. This is a special electrophilic substitution reaction, special reactions of phenols. First one, very important reaction, that is a cooking reaction. Phenols, they couple with the diazonium salts, this one, diazonium salts, in mild alkaline solution, that is a basic solution, to form hydroxyazo compounds. Now, let us see the reaction. Here, this is benzene, diazonium chloride. This is benzene, C6H5, that is phenyl group, benzene. Next one is di means 2, aza means nitrogen, chloride, benzene diazonium chloride, C6H5 and the Cl. This is treated with phenol in presence of mild and that is weak alkali, that is base. Then we get this compound, that is this this compound, the H from this para position of this phenol and the Cl are removed as HCl. The rest is the product obtained here. That is para hydroxy. This is para position hydroxy. This is azobenzene. This product is known as azobenzene. C6H5 and double bond C6H5. This one. So this is azobenzene. This is para hydroxy. Azobenzene is the product obtained. This is known as coupling reaction. That is azo-coupling reaction. Next one is Kolbe reaction. Kolbe reaction is the reaction in which sodium salt of phenol is heated with the CO2 gas. sodium salt of phenol, that is sodium phenoxide or sodium phenate, is heated with carbon dioxide, CO2 acid, at 120 to 140 degrees centigrade under 6 to 7 atmosphere pressure. So conditions we are maintaining here 6 to 7 atmosphere pressure and 120 to 140 degrees centigrade around. Okay. Then a carbonyl group, that is a COOH group, or the salt of COOH group, is introduced mainly in the ortho position to ortho position to form orthohydroxybenzoates. Orthohydroxybenzoates. This reaction is known as Kolbe reaction. In Kolbe reaction, let us see this. This is sodium phenoxide. That is sodium salt of phenol we have started with. To this, carbon dioxide gas is added on heating to 125 degrees centigrade at about 6 to 7 atmosphere pressure. Then we get this compound. When the sodium is not, it is not salicylic acid. That is, it is nothing but sodium salt of salicylic acid. That is nothing but sodium salicylate is obtained. Now, when this is subjected to hydrolysis, the bond breaks here. H we will get here, OH over there. Then we get the acid here, salicylic acid. So, the sodium salicylate, when it is subjected to hydrolysis, that is, add water and heat it in presence of acidic hydrolysis, then we get salicylic acid as the main product. This reaction is known as Kolbe's reaction, which is also very, very important reaction. So at high temperature here, this is at low temperature, the temperature is less, 120. At this temperature, we got ortho product. At high temperature, para isomer is obtained as a main product. That is, the COONA is attached here. So these are the chemical properties of phenols. So hope you are all doing well. Stay home and stay safe. Read well. Prepare well for the examination.